All right, so this is a continuation of 14.3 on probability and addition, the day 6 notes. So on the front side, we really focused on probability, but now that we're on the back side, we're going to focus more on the addition rule. So we need to know, what is the addition rule, how do I apply it, and when do I apply it? Well, if I'm going to apply the addition rule, we need to know have a reminder of some of the basic symbols that are going to be involved in it. So first of all, there's this symbol that looks like a U, and that stands for union. And this is when you combine two sets together to get one bigger set. Then there is the upside down U, and that upside down U stands for intersection. And the intersection is when you identify common elements in two sets and use those to create a smaller set. Because that smaller set only contains the things that are in common. So let's look at this example here, right? We have a set A, and these are all the elements in A. We have a set B, and these are all the elements in B. Now remember, this one here stands for union. So we're just going to combine them together. When you combine them together, they have to be in order numerically from smallest to biggest. So remember that there's this loop, arrow loop to create this set, that set notation. Then 1, 2, 3 would come next. 5 would be next. There's 7 in both of them, but I only count it once. 9 would be the next highest. Then there's 12 in both of them, but again, we only write it once. 15 and 17. So we should probably make ourselves a little reminder. When we do a union, the common numbers you write only once. Okay, because when we put them together, if we already have a 7 in there, we don't have to have a 7 written twice. So the common numbers you only write once. Now this one, remember, stands for intersection. And so we're just looking for the things that are in common. So there's not a 1 in both of them. There's not a 2 in both of them. There's not a 5 in both of them. There's not a 3. But there is a 7 in both of them. So the first number or first event in my set is 7. 9 is not in both of them, but 12 is. So 12 will have to be part of it. And 15 and 17 isn't in both of them. So my intersection set is 7 and 12. Okay? So you need to use these ideas to combine probability. I should say to combine probabilities, which is what the addition rule is all about. The addition rule is all about combining probabilities. So I'm going to make a line across here because this is all just the reminder stuff, and the bottom is all the new addition rule stuff. So the addition rule is this: the probability of A union B is equal to the probability of A plus the probability of B. But we need to be careful, right? Because remember from before, we wrote any of our common numbers only once. So if we're writing it only once, then just adding our probabilities isn't enough because there's going to be common ones that we should have wrote only once. So then we're going to subtract out the probability of A intersect B, because the intersection would cancel out those common events that had happened in both of them. Okay, so what this truly means, if we're breaking this down, is that we are trying to find the probability of two things. Trying to find probability of two things occurring. And if we're trying to find the probability of those two things occurring, our first step would be to find probability of each, and then add them together. That's what this is saying. Find the probability of the first, find the probability of the second, and add them together. Once we've done that, then we need to take care of this step, which is subtracting out the common elements. Subtract out common elements. In other words, the events that happen twice, or that happen in both. That way we don't count them twice, we only count them once. Just like here in this union, we only wanted to count them once. So we had to take out 7 and 12 because that had occurred twice. We only wanted to list them once. All right, so let's take a minute and look at our example. In tossing a pair of dice, so we're talking about tossing a pair of dice, right? So they are asking, what is the probability that the dice either adds to 8, so that's one of them that we're dealing with, or has at least 1 2. So the probabilities that we're talking about here, and I'm just going to write this off to the side, is we're trying to find the probability that they add to equal 8. Then we have to go ahead and find the probability that there is 1 2 in the set. So if I'm going to find the probability, and we're talking about dice, then we again need to know probability is what you want, right? Divide it by the total number of options, or the total events. So we need to find those total events, right? So if I were trying to find the total events in a die, right, we're tossing a pair meaning 2. So I have 2 things that I'm rolling, and if I'm rolling a die, the options are 1 2 3 4 5 6. So there are 6 options for the first die, there are 6 options for the second die, and I multiply them together to get 36, or not 36, 36 total options. Okay. And so that's our starting point with this. Okay, so 36 total options is going to be the bottom part of our denominators. So let's start out with the probability of this one, because basically you have to find the probability of each, right? Add them together and subtract out what occurs twice. So I'm going to start out by finding the probability that they add to equal 8. So let's make a list of numbers that can add to equal 8. So if I roll a 1 as my first die, I would want 7 so that they would add to give me 8, but 7 is not on the die, so that wouldn't work. So then I try 2. Would 2 plus anything give me 8? Yeah, 2 plus 6, so that works. And then 3 plus 5 is 8. And then 4 plus 4 is 8. And then the reverse is true, right? 5 and 3, 6 and 2. So if I'm saying the probability that the 2 die add to give me 8, there are 1, 2, 3, 4, 5 ways to get them to add to equal 8 out of 36 in total. Okay, so there's 5 out of, and that doesn't reduce, so we would leave it that way. So there's 5 out of 36 ways to add, that the probability adds to equal 8. So this is a huge part of the beginning of this, because now I have found my first probability. Then I need to go find the probability of the second thing happening. So the probability that there's at least 1 2 in it. Well, we can start out by listing it. If my first thing's a 2, then it could be 2 1, 2 2, 2 3, 2 4, 2 5, 2, 6. And then couldn't the reverse of each of these also have a 2 in it? So 1, 2. 2, 2, we can't reverse it because it would be the same thing. Then 3, 2, 4, 2, 5, 2, and 6, 2. So these are all the ones that have a 2 in it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 out of 36 ways to get one of them to be a 2. So here's my second probability. This is that one up here that we were trying to find. Okay? So now we look at this and we say, all right, we need to remind ourselves that we are trying to do the probability of the first thing plus the probability of the second thing minus the probability of any common elements, because we need to get rid of counting them twice. So the probability of A was 5 over 36, plus the probability of B is 11 over 36. And now we're subtracting out however many out of 36 that are common elements. So if I look at my list here, we have a 2, 6. There's also a 2, 6 in this one. So that's one common element that I'm going to have to take out. I'm just going to make a tick mark to keep that track of that. Then 3, 5 is in that. Well, 3, 5 isn't in this one. 4, 4 isn't in this one. 5, 3 isn't in this one. But 6, 2 is in both of them. So I have two elements that are in common. So I'm going to subtract out 2, 36. Okay? Because we have to, again, add the probability of each and take out whatever's in common. So 5 plus 11 is 16. And 16 minus 2 is 14 out of 36. And then we need to go ahead. Sorry, it'll come back up in a minute, the light. Okay, so 14 out of 36 reduces to 7/8. So this is my probability that they add to 8, or at least 1, 2. This rule is particularly important and useful when you can't write out subsets. This idea of adding them together and subtracting out the common. This is, so just a reminder, so add probabilities and subtract common elements. Add the probabilities and subtract out the common elements. This is mostly used mostly when list out subsets, or if two probabilities need it. Note, if there are no common elements, simply add the probabilities. No need to subtract, because there's nothing to subtract out if there's nothing in common, and I'm sorry you couldn't see that. So if there are no common elements, simply add the probabilities. If you couldn't see that and you need to pause the video to copy it down. Otherwise, we're moving on to the last page. Okay, so we're going to do example 1 and 2 together, but number 3 you are going to try on your own. All right, so let's read through number 1. At a local college, 48% of the students use only electronic textbooks. 66% of the students are female, and 24% are female students using only electronic books. If a student is chosen at random, what is the probability? So what is the probability that they either use only electronic books or are female. So we're trying to find the probability electronic or female. So when we're thinking about this, this tells me that there's two different probabilities that we have to find. Probability of the electronic, which they already gave us as 48%, but now if we type it in as a probability, we need to make it a decimal or a fraction. I'm okay since it's a percentage if you leave it a decimal, so this would be 0.48. So the probability that it's electronic is 0.48. Then I need to find the probability of the female. And there are 66% of students that are female. So that means 0.66. So this is 0.66. Now remember, when we're doing this, right, we take the probability of the first one, we add the probability of the second one, and we subtract out the probability of where those things intersect. In other words, the common, right? So right now, 0.48 is the first one, plus 0.66 is the second one. Now, is there anything in common? Well, when we read on, didn't it say there are 24% that are female students only using electronics? So that tells you that's how many are in common in both of them, because they're both female and doing electronics. So they're doing both of these, so we're going to subtract out the 0.24 because this is what is in common in both of them. So if you were to type that in your calculator, you would end up with 0.9 is the probability of electronic or female. Okay, last one we're going to look at together. What is the probability of either getting a sum of 11 or doubles when you toss a pair of die? So this is that same basic idea. We're going to have to find the probability that they add to equal 11. We're going to have to find the probability that they are doubles. Now doubles mean the same number twice. Number for both die. Okay? So if I'm going to do probability, again, we should start out with what is in common between them, right? So, because it's out of a total. Out of a total, right? So what is this total? So we're rolling 2 die. So 6 times 6 means 36 is the total possible combinations. So there's 36 total combinations, so I know right away that the probability, the denominator on the probability for both of those will be 36. Now I need to list out ones that add to give me 11. So let's think about this. 1 plus 10 is 11, but 10 is not on the die, so that won't work. 2 plus 8 is 11, or no, not 11. 2 plus 9 is 11, but there is no 9 on the die, so that won't work. 3 plus 8 is 11, but again, there's no 8 for the die, so that won't work. 4 plus 7 is 11, but no 7 on the die, so that doesn't work. So then 5 plus 6 is 11, and both of those are on the die, so that'll work. And then 6 comma 5 adds to 11, so that will work as well. So there are only 2 ways that I get die that add to equal 11. So the probability that it equals 11 is actually 2, because there are 2 options to get what I want, out of 36 total. Now we have to do the probability of getting doubles. Well, 1 comma 1 is a double, 2 comma 2 is a double, 3, 3, 4, 4, 5, 5, 6, 6. And you do need to list this out to show your work. So there are 1, 2, 3, 4, 5, 6 out of 36 possibilities to get a double. And I normally wait to reduce until the end, right? So now we have to think about this probability again, right? It's probability of the first plus probability of the second minus probability of anything that's in common between the sets. So probability of the first is 2 out of 36. Probability of the second is 6 out of 36. Now, are there any common elements here? Well, these are all the the same thing twice, 5 and 5, 6 and 6, and that doesn't happen there, so we'll subtract out 0 out of 36 because there are none in common. So since there are none in common, we would just subtract 0. So 2 plus 6 is 8 minus 0 is 8. So this gives me 8 out of 36. And 8 out of 36 reduces to 2/9. So the probability of adding to equal 11 or doubles equals 2 out of 9. All right, so now you need to try that last one on your own and come in ready to ask questions in class tomorrow.